Hello everybody. In this video we are going to introduce SI units of mass or metric units of mass. So the mass of an object refers to the quantity of matter in the object. So how much matter makes this object up, okay? So the amount of matter that makes up an object does not change no matter where the object is located. So the amount of material that makes up an object, it doesn't change where the object is in the world or in the universe. So the mass of an object, the mass of, let's say, a block on Earth is equal to the same mass of the block on the moon, okay? Now, when we talk about mass, sometimes we think of it as weight, but just keep in mind that scientifically those two things are different. Weight is always in relation to gravity. So on Earth, your weight would be higher than on the moon because there's less gravitational pull, a pull downwards on the moon. So if it helps you to think of mass, as how heavy something is, sure, just make sure that you know that weight and mass are not the same thing. Mass is how much matter makes up an object. So the metric units of mass, the SI units of mass, are milligrams, grams, kilograms, and tons, and so on. So just, please note the abbreviations. Milligrams is mg, grams is g, kilograms is kg, tons is t. So before we continue, I have some notes I want to talk about. So first, in the metric system, kilograms is the basic unit of mass. And when I first learned this, I was shocked because I thought of meters, how meters is the base unit of length, and everything else is related to meters. So millimeters, centimeters, kilometers. But in this case, it's different. Kilograms is the base unit of mass, not grams. So keep that in mind. Now, the other thing I'd like you to pay attention to is the spelling. So tons and tons are different. They are spelled differently. They are not the same thing. In the metric system, we are working with this one, this tons, the one with the extra NES. Sometimes ton is referred to as the metric ton, okay? So just know in SI and metric, we're dealing with this guy, okay? So now it helps to visualize what each of these SI units of mass would actually look like in real life. So we're going to talk about reference. So I'm going to write this here. You may have heard this or read this before, but a referent is an object that we use to help us visualize the quantity of something. And it's really, really helpful for estimation. So I'm going to explain what that means in a few seconds. So to visualize, 1 kilogram is approximately, roughly, the mass of, a good-sized textbook, okay? You can also think of it as the mass of 3 apples. So here, for example, that textbook is my referent. If I want to visualize 10 kilograms, I'm going to visualize 10 good-sized textbooks, okay? To visualize 1 ton is approximately the mass of a 79 Volkswagen Beetle or 2 adult male polar bears. So that is huge. So 2 of these, okay? 1 gram is approximately the mass of 1 button or a small earring or a $5 bill. So if something weighs 10 grams, imagine 10 buttons, okay? 1 milligram is very, very light, so it's approximately the mass of a small feather or the lead of a pencil, okay? Now, if we wanted to arrange these units from smallest to largest, say 1 milligram, 1 gram, 1 kilogram, 1 ton, milligram would be the smallest, then grams, then kilograms, then tons. So this is the smallest, and this is the heaviest or the largest, okay? Now, the unit conversions are as follows, and I recommend that you write these in your notes. I know they're in your formula sheet, but it may help to write them down, and that will help you remember them and retain them. So 1 kilogram is equivalent to 1,000 grams. So again, think of 1 kilogram as 1 good-sized textbook. In grams, so that would be 1,000 grams. Think of that as 1,000 buttons. So 1,000 buttons is about the same mass as a good-sized textbook, okay? Again, we're just estimating with the reference. 1 gram is about the size or the mass of like a button, and that's equal to 1,000 milligrams. So that's like 1,000 little feathers. So 1,000 of those feathers would be equal in mass to 1 button. Okay, 1 ton, so that's like 2 male polar bears, is equal to about 1,000 good-sized textbooks. So 1,000 kilograms. Okay, so these are our unit conversions. You'll always have those available to you in every module, with every quiz, with every test. Okay, so now what we're going to do is we're going to practice converting units. Okay, so first question is convert 1.75 grams to kilograms. Okay, so this is going to be very similar in approach to converting units of length and so on. So all we need really is the conversion factor. So we're going from grams to kilograms. So I am going to look up and I'm going to find the relationship between grams and kilograms. And there it is. 1 kilogram is equal to 1,000 grams. And now I'm going to line up those numbers. Grams here comes first. So it's 1,000 grams is equal to 1 kilogram. Okay? So now I have to think, how am I moving from 1,000 to 1? Am I multiplying or am I dividing? Because the numbers are getting smaller, we're going from 1,000 to 1. We are dividing by 1,000. Why 1,000? Because 1,000 divided by 1,000 is equal to 1. Okay? Now that is the relationship between grams and kilograms. I am going to use that exact same relationship to convert this number to this number. Okay? So I am going to divide by 1,000, and that will give me 1, 2, 3. That will give me 0.00175. And you can, of course, use your calculator. You don't have to move the decimal the way I did, but if you know how to do that, that is great. Okay, so 1.75 grams is equal to 0.00175 kilograms. Remember to always write your units. We're working in measurement here. Alrighty, next example. We're converting from kilograms to tons. So I'm going to go to my conversion sheet, to my formula sheet, and I'm going to find the relationship between kilograms and tons, and here it is. 1 ton is equal to 1,000 kilograms. So I am going to write that down. Kilograms comes first. So I'm going to write kilograms. 1,000 kilograms is equal to 1 ton. Okay, it's going to be very similar to the previous example. So the number is getting smaller, so we will divide by 1,000, because 1,000 divided by 1,000 is 1. Here I'm going to also divide by 1,000, and the answer is going to be 6.137 tons. And of course, you can use your calculator. Okay? All right, next example. We're converting from tons to kilograms now. Okay? So we know that relationship. We just used it up here. But this time, the tons comes first. So it's 1 ton is equal to 1,000 kilograms. So to go from this to this, the number is getting larger. 1 times what gives me 1,000 times 1,000. Okay? So here I'm going to multiply by 1,000, and that will be 25,000 kilograms. Okay? All right. Now let's continue. We're going to do some word problems together, and I don't think we'll have enough time to do all of them in this video, so I'm going to split it into 2 parts. Please feel free to pause the video before I solve the question so you can try it by yourself. If you struggle, if you get stuck, that is okay. It's all part of learning. Just make sure to come back and check your answers and check your solutions. All right, so let's have a look at the first question here. The blue whale can grow to over 170,000 kilograms. What is the mass in tons? So what is the information given to me here? What's given is the mass, which is 170,000 kilograms. What do we want? We want that mass in tons. Okay, so 170,000 kilograms. What does it equal in tons? This is the question that we're answering. So isn't that very similar to this example right here? We're going from kilograms to tons. So we're going to follow the same procedure. Okay, I know from my formula sheet that 1,000 kilograms is equal to 1 ton. So to get from here to there, we divide by 1,000. So here I'm going to divide by 1,000. And that will give me 170 tons. So I'm going to write a summary sentence. The mass of the blue whale is 170 tons. And I put the units because that is important. All right, let's try the next question. I'll leave it on the screen for a few seconds. Okay, so the Smith's baby was 3,125 grams at birth. How much did the baby weigh in kilograms? Now, if this is strange to you, I know in Canada we use imperial units, like pounds and ounces, to measure babies' weights, and even adult human weight. In Europe and many other countries around the world, in Asia, they use the metric system to measure weight and mass. So they use kilograms and grams. Okay, so here we want to know the Smith's baby's weight in kilograms. So what we want to know is 3,125 grams. What does that equal in kilograms? Okay, so take a second and look at your formula sheet. What is the relationship between grams and kilograms? Now, if you look at your formula sheet, you'll know that 1,000 grams is equal to 1 kilogram. And again, I will say this over and over again. Watch how I line these up, okay? The grams on the left, kilograms on the right of the equal sign. To go from 1,000 to 1, we divide by 1,000, okay? So here, I'm going to divide by 1,000. So the weight of this baby is 3.125 kilograms, okay? So let's write a summary sentence. The baby weighs 3.125 kilograms. And again, units, okay? All right, so I am going to stop here for this video. The next video, I will do more word problems with metric units of mass.